Hi. Now, in this question, we're asked to show that the integral of 18 all divided by the root of 6x plus 1 integrated with respect to x between the limits x equals 0 and x equals 4 comes to 24. So, if you'd like to have a go at this and haven't done so already, just give you a moment to pause the video, do come back when you're done, and you can check your work solution against mine. Okay, welcome back then if you had a go. Let's see how you got on. Well, first of all, just going to take the integral going from 0 to 4. We've got 18 then, all divided by the root of 6x plus 1. Okay, integrated with respect to x. Now, the 6x plus 1 with the root round it, we can think of this as 6x plus 1 to the power half. But then if I bring it up to the top, it becomes to the power minus a half. So we've got 18 multiplied by 6x plus 1 all to the power minus a half. And that's integrated with respect to x between the limits x equals 0 and x equals 4. Now, not all integrals can be integrated by recognition. This one can be though, because what we've got here is inside the brackets something of the form ax plus b, and I notice that if I differentiate this I get a constant, and I'm multiplying this by a constant, the constant 18. So with practice we should be familiar with the idea that we can try out the differential, let's just put it down here, of something of this form. What I'm going to do is differentiate, okay, with respect to x, 6x plus 1, and I'm going to add 1 to the power, so it'll be to the power half. And what I'm hoping for then is that when I differentiate this, it will end up as being a constant multiplied by 6x plus 1 to the power minus a half. Now, that constant is not necessarily going to be 18. I'm just going to put a constant in here. I'm going to call it a. And let's just differentiate this now and see what we get. The constant is going to remain there, okay, because the constant is being multiplied by a function of x. So if I differentiate 6x plus 1 to the power half in the usual way by the chain rule, it will be a half multiplied by 6x plus 1, and then we reduce the power by 1, so that's 6x plus 1 to the power minus a half, and then we multiply it by the differential of the inside of the bracket, which would be 6. So that's the chain rule in differentiating 6x plus 1 to the power half. I'm assuming that you're familiar with that. Now we can tidy this up. I notice that the 2 will cancel into the 6 3 times. And so what we end up with is essentially the 3, okay, here, multiplied by the a, let's just put that in red, multiplied by 6x plus 1 to the power minus a half. So if I had to integrate this, the answer would be a multiplied by 6x plus 1 to the power half. And that's essentially what I am integrating. I've got a constant here multiplied by 6x plus 1 to the power minus a half. And that constant is 18. So I need to find out what a is. Well, it's pretty obvious, it's 6. But what I'll do is I'll just write it down. I'll just write down that 3a, okay, must equal the 18 that we've got here. And so therefore a must equal 18 divided by 3, which is 6. So now I know that if I had 18 then times 6x plus 1 to the minus a half, which I've got, I must have differentiated a being the 6 times 6x plus 1 to the power half. So the integral of this then is 6 multiplied by 6x plus 1 to the power a half. And we've got the limits between 0 and 4. I'm going to pull the 6 out, okay? Again, I don't have to do that, but we're integrating between the limits 0 and 4. So if I just write this then as the root of 6x plus 1 going between 0 and 4, then just substituting my limits in, putting 4 through first of all, I've got 6 times 4 is 24, plus 1 is 25. So I've got the square root of 25, and then minus, and I put 0 through, and that gives me just the 1, the root of 1. And so I've got 6 multiplied by 5 minus 1, 6 times 4 in other words, which is 24. And that's what we had to show. Okay, so I hope you were able to get that if you did it by recognition. If not, that you can follow how it's done. There we go.